And here we are live on Twitch. And welcome back everyone. I'm happy to see you again. We are on Twitch, we are on Instagram. On Instagram we have some smooth jazz, which is cool. And on Twitch we still doesn't have some music, but I think I will try some free music. Maybe next week I will try to find something. Yeah, so here we are for November number 16. And let us begin. So first of all, I will simply make a little tweet about the fact that we are on Twitch and Instagram. Let's see if anybody wants to join us. Not sure, but hey, why not? And let's retweet that. Okay, here we are. So what do I want to do tonight? So yeah, yesterday we pursue our little journey around fur shader with this little guy here, inspired by parrot colors and with some poppy fur, and I wanted to explore the fur growth. And at first I was saying that it was the last fur shader I wanted to explore, because I might want to go back to something more art surface and something like that. But then I reconsider, and basically I think I want to mix something like that with something else. So I've checked back some of the experiments we've made lately, and there is one which is quite interesting, which is here. Remember this one, which is a hard surface, and basically we take some kind of crystal shapes, and we've put some nice reflection on it, and it was kind of interesting to have this little guy here. And I was thinking maybe mixing something like that with the fur, using the noise, with some noise growing on the shape. And it's basically something like inspired like this one, for example. Also, this one, I don't know if you remember, on this one we had this little mosses we've made using noise shader. So I think I want to a little bit go back to this part. I've just seen that when I've explored some natural elements, something like that or like that, I've just seen that I didn't explore the wood material. So I have this idea about exploring the wood material, and at first it was an idea that I think I would make maybe tomorrow or the day after, etc. We're using some wood ball which can fall and then bounce, but I don't want to produce this idea tonight. I think I want to produce some kind of hybrid of some other experiments. So maybe having some log, some wood log, which may compose the body. So a little bit like the experiment we've made with the rocks with the precious rock. So having some log, and maybe on the log we can have some growth on it. And what's helped me to think about that? It's a project made by Tavo Studio, which is, by the way, a great motion design studio. So let's find them. So I think it's Tavo Studio or Tavo Design. They made the last they had a lot of the beautiful things. They made the last open title for the DDD festival, which is the Digital Design Day. So do we have this or not? This is them, and we have multiple. Yeah, Tavo. Here they are, Tavo and Behance. And yeah, this one, and this was especially this one. And I think I already show you. I think they are one of my favorite studio lately. Beautiful color, beautiful elements, etc., etc. So yes, I made this little open title, which is really beautiful. Let me just click pause on the sound, just to be enjoying the full shot. So let's hope it will load. So as you can see here, I think you know where this is going. So basically there is a shape which is the D of the DDD festival, and you will have some nature growing on it. Wow, this color are just beautiful. It's really impressive how they work. It's like a micro universe, and the reflection is really interesting with a little bit of blur, and it's really interesting. A nice back reflection, backlight, sorry. So yeah, let's go on Vimeo. It seems it's so yeah, this is their open title, and it's really beautiful, and I invite you to follow them, especially on Twitter, Instagram, on each platform you can see them. Where you can see them, it's really they made a lot of beautiful work. So yeah, this is my inspiration. So basically I want to explore this kind of things, not purely this one, but this kind of thing. So wood, some fur, some growth based on the noise. So we have the fur, we have the growth, we have the noise. We don't have the log, the wood log. So I found one. here, which is free. It seems to have a Unity package. So let's check. Unity, what does it have? Unity package seems to have a normal, an albedo, and a specular. So yeah, might be good. Okay, let me take that. Okay, we have this, and where is the file? It's here. And let's go to our dev Codevember assets model, and this would be something like woodlog. So woodlog, and let's paste here inside our elements. So as always, first thing first, let's create a new scene. Let's duplicate all the elements we will need for this scene. So let's save this little scene here as the element 16. Okay, then in the element 16 we will need a new GPU mesh controller. So we use the two, we use this two. Yeah, if you remember correctly, the first one was based on the rig and the second one was taking the vertices. So we will take this, the two controller and the two GPU mesh controller. So we will need the two of them. Do not delete them, but we will need to rename them as 1116 and 1116. So if you are seeing this stream not live, I invite you to just forward a little bit, maybe 1 or 2 minutes, because we made this a lot during previous streams, so it's really not complicated. I'm simply getting the name, renaming everything as 1116, and then it will work. Oh, and I need to going back with my smooth jazz. Oh yeah. Okay, 16. Okay, we have our controller, it's the 16, so let's remove the component, let's remove this component, let's remove this component, and take back our elements. Okay, just to check, yeah, we didn't set a lot of instances. It was this default. Okay. One. I'm not sure if we will change the compute shader, but I think so. So you know what? I prefer to duplicate it, even if we simply don't change anything in the compute shader. I prefer to duplicate it, because if I want to make some change, I don't want to override the 15. So let's try this new one. And in terms of material, we will create a new one, and it will take some time, because as always it's a first shader, so it makes some time to recreate. Okay, seems to be really good. I hope so. Pam 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 pa. Okay, controller. and 16. So if everything is correct, okay, if everything is correct, we can save our scene and we will see a little furman like yesterday, which is, so it's okay. Then what? Then duplicate the shader, of course. So let's take the shader 16 and let's take the material instance shader 16, which again will take some time to compute because we have a lot of passes inside this one. My hair are quite a mess, but nah. Oh my. We need to rename this a little bit to be 16. And you know what? Just to focus on the log, I will comment all these little passes right now. Maybe I will only keep few of them, so you know, so maybe the first 5, for example, just to be sure. So let's select 1, 2, 3, 4, 5, and let's comment everything just to be able to compile our shader quickly and quicker. Okay, so in this I could now in the custom select the 16, which will have exactly the same but with less fur because of this. So it has some fur, but really we don't see them. Okay. So here we are, and at first let's focus on taking the log. So let's try our little log. Oh, and of course I need to say that we would use not this, but I will never remember. Oh, okay, this stuff. So, oops la, we will use the 16. And here we use the vertex 302, which is this one, which is basically the same. So okay, perfect also. Okay, then let's focus on the log. So where was I? I was here. It's a normal map, so apply. We have some albedo and albedo transparency, which does it have some transparency? I think so. I think not. Doesn't have any, so not a problem. Okay. And we have this, which seems to be the smoothness. Okay. So if I put this, oh my, it's a big log. Okay, 0, 0, 1. Maybe I want something a little bit smaller. Something like that might be interesting. Okay, let's create a simple material here. I will name it log just to test, just a test material. So here our log, and we will put some normal mop inside of it, and some albedo and some smoothness. I think I kind of like it. Very interesting, really interesting, especially on the color, etc. So if we change the smoothness, it changes a little bit. Okay, so let's change our little cylinder here by that. So okay, and in the 16, this is our little material. We will need to change some things. Of course, we will need to have some distribution, but let's not focus on the distribution, and let's comment all the fur part for the moment. I will only focus on retrieving the log value. Okay. So let's take this. Okay, and now the log is invisible, which is quite normal because we've disabled this. As you can see, it's appearing, disappearing. We have a little guy here which seems to be alone. I thought we found a way to get rid of this one. I thought we come to the solution with this. I thought we had a solution on this one. Let's remove this part. The base alpha, let's keep it. We'll remove this part also. And now we might have some lighting, but we need to have a surface standard output. As you can see, we have this. And why does this post-process? We still have this. It's quite strange, but let's get rid of the ambient occlusion. Yeah, we were having a problem of lighting. This was our problem lately. Yeah, I remember which one helped us was the add shadow tag. I forgot this one. And it's okay now, you can see the occlusion. Okay, so we have our little log here. So let's go back to some of the other shader just to check and to find which one we've used when we use some quartz. Yeah, it was the 11. So I need to go back to the 11. So we need to get few value, which is the world reflection and the internal data, everything like that. So suppose we already have that. So okay, I'm taking this value because we will need. So we need some bump map. The ambient occlusion, we don't have it. We have some metallic map, some smoothness in fact. So this is the color, this is the main text. Of course I would need some bump map. Let's get this to the fur in fact. Okay. Oh yeah, it's recompiling some old shader because I've changed the vertex 13 underscore 2. Sorry, recomputing everything to put the new value. Okay. Now I can put my bump map. So let's check again. As you can see, if I put some metallic, I can have the smoothness here. So the glossiness is basically the smoothness. So now metallic would be, let's put this before that, and it would be a color, so a color texture. So okay. We would need to change on this also if we don't want to have an error. So we still have, I think I will say something like 16.2 just to be sure, because I will need to change some of this, of course, because it adds some metallic here. So the metallic would be a sampler 2. This would be also the case here. And we will need, of course, some sampler, cube, and global emission here. Okay. And we would take all of this. Oh, and yeah, we have some luma. Do we need the luma? Yeah, maybe. Let's put the luma. I will clean up later. So something like that. Okay, so we have the RGB, which is the main text, so not a problem. We have the ambient occlusion, we don't have that. We have the roughness, so we don't have this texture. We have the metalness, not a problem. So metallic, okay. We have the normal, which take the bump map and the UV bump map. So UV bump map is declared here, so it's not a problem. So now we can use this. So this is correct. So we would simply say that o.color is equal to a float 4 of 1111 at first, to be sure to have some color here. The normal would be the normal, not a problem. The metallic would be the metal. The smoothness could be the glossiness. Then the emission is basically our sampler cube, so not a problem. The emission could be this, so not a problem also. But remember, if I said that, so we would have a problem. We would have a problem because let's recreate everything. So yeah, text the day, no matching what? Metallic is white, metallic. Oh yeah, because it's, I haven't changed this. Okay. So now basically it's not perfect because, let me reduce a little bit the music in my hair. Okay, so it's not perfect because if I basically where is my, okay, I think if I augment this, you could see that the reflection is really defined, so it's really not perfect. You could especially see that if I change the HDRI, or you know, so as you can see, it's really defined. So we need to change this to don't have this extremely defined reflection. And remember, we use a LOD, so this could be really interesting. And what we used for that was this little guy here, so we simply change this by this. So we use the text cube LOD, which can take the MIP map of the cube, and we set the normal, and we have this. And basically we've used the metallic value, 1 minus the gray. 1 is really defined, so I think it could be good. And I don't need the fair multiplier here. So now I might having some more, oops, seems we have an error somewhere. Cube, normal, metallic, it's a metal dot r, something like that. It's still really defined. I think I would put something else, maybe some value here, which is the enviro blur, environment blur. Uniform float environment blur, and let's put also this little guy here, and now I can use it in this little element. So I think 0 is defined. I don't remember if 0 is defined or if it's 0 is really blurred. So I think 0 is really defined. Yes, that's it. 0 is really defined and 1 is more. So yeah, Now you can see really the importance of some nice environment map, because it's give really a lot of variation on the lights, so it's really interesting. Okay, so what do we have? We have this, so it's okay. We have the metalness, which I haven't set, so it's this one. We have the smoothness, so we can change it a little bit. So as you can see, we can change the smoothness, so let's say something like 001 or 002. Well, I think it's okay for me. We could add a little bit of the of this, but this one was not really interesting. Okay, so let's say something like that. Why I think it's not interesting, it's because if I use the luma of the albedo, I will simply add a lot of white directly into the emission, so I don't want that. So maybe it can simply be a simple add. So now I can keep a pure emission, and let's say something like simply something like that. In fact, simply just add some emission directly from the albedo. So we can, as you can see, add some little bit of okay, let's go back to something more. Okay, so we have the system, so we have the base shader. Great. Now maybe we can focus a little bit on the position of our mesh directly on the element, and then at last we will focus on the third part. So just to be sure to be able to simply change anything we wanted to change here, I will simply say that this would be, I will keep everything like that, but as we use the metallic here, I will simply say I will use the environment blur, so this would be better. Okay, maybe we change some value if we want something more emissive for the fur than for the log. So okay, so let's go back here. What do I change and what do I put? So yeah, I reactivate the normal list. So what I have in mind here, for a quick moment, let's consider, let's re-see our little guy here made of log. Okay, let's put something with 1 and no rotation at first, and let's put, I don't know, maybe 100 of them. Okay, so now we have a little woodman. Okay, let's put a little bit of randomness into it. So okay, so I'm not quite sure about this this man, so something that might be interesting, I think, but let's check, is at first, just to begin with, retrieving what we've already made a lot, which is simply bind our log directly on the on the vertices and following the normal. So it would be some like of spike event. So I like to start with some spiky elements. And we might notice, and I think it's the case, we also might notice that our log is as its pivot on its gravity center. So if I put something directly on the vertex, following the normal, it will go on this side and also inside. So maybe on the end it would not be quite interesting because it will be too messy. So why not first check where are these pivot points, then maybe we can just put on the base and start with that, then align it with the normal, and then try to disturb a little bit. That's because I was thinking maybe having some log directly more randomly distributed on the base, and then the more we go up on the mesh, the more the log might just stand right. So it would be something like maybe a kind of pyramid. I'm not sure about the result, but it might be some kind of interesting. So I was talking about checking the pivot point of our log. So let's try that. Let's import it, and no, it's kind of perfect. In fact, for what we've used, the log is directly on its base. So I was convinced that it was not the case, but I haven't checked it. Oh, right. Welcome, Mr. Dekiril 20061, which want me to buy some follower primes and viewer on some random Russian link, bigfollowers.com. I really don't mind, and I really don't want to click on some scams, so no thanks. So yeah, talking about our little log band. So I've pushed the normal directly to our elements, and yeah, this is it. So we take some random value, and I think we will need to check something like the GPU Mesh Controller 11, because we have everything ready in the GPU Mesh Controller 11. So yeah, we've used the position, we have the target, we have the look. So remember, the target is the position plus the normal, just to see some point, and then where is this one. So we will have to look into this one. So basically, in fact, we have this little guy here, and we also made some kind of max rotation. So okay, first of all, let's take this little guy here. Okay, for the rotation I will simply just a little bit comment this part. Of course the position is simply that. Okay, so by saying that, I might having a little guy with some spike made of wood log. Oh, and we multiply by the norm y, so I don't need that right now. I just want to see our little guy. Let's put a lot of them, and let's try to reduce this just to check. Okay, that was the main idea. It's clearly too small, but that was the main idea. So let's go back with 100 with the size of 1 just to be able to see what we're working with. So now that we're following some normal, we might add some random rotation. So first of all, we can try what I said, which was to be able to change the rotation. Multiplying by norm y, maybe? Not sure. Yeah, we have an error. Quaternion by float cannot apply operand, of course. I'm not sure about this one. You might end up with something really different. As you can see, it's only based on the rotation, on the last rotation. But I think we have some quaternion.lap, which might be more interesting. So maybe we can simply say that rotation is equal to quaternion.lap. So let's check if it's exists. I think so, but I'm not sure. Quaternion lap unity. Yeah, quaternion.lap exists. So I need to go from quaternion.identity, which is basically the base rotation, to rotation based on the norm y position, which is basically the normalized position of the vertex on the y-axis. So yeah, is that what I mean? Or not? I'm not sure. Looks quite interesting. If norm y is equal to 0, I might end up with some so 0 is this. What to norm, I will take this, I will call this like that. I will go to that, and this is a quaternion, and here we are. A little bit interest in the rotation. In fact, let's put some times on it, just a little bit. Okay, so if I say something like that, so we have this, so this is the max rotation, so it's okay. If I say something like rotation, oops, it's a region. Rotation, as we saw, something like this is multiply and equal to And if I rotate on the x-axis, which is this one, I might end up by going behind the shape. Okay, so something like that. I hope so. Let's look into it. I don't want to put too much time into it, but yeah, this was the idea. Okay, and if I simply change it a little bit, saying 0.25 for example, so in fact rotating by 90 degrees, it's not the best value, which will be more like 90 minus 19. I want to have some kind of directional, and if this direction now is simply based on the normalized position of the vertex position on the y-axis, do we have something interesting? So we in this case we'll not have any rotation on the base. It's kind of interesting. It's kind of interesting because position is quite strange, in fact. I'm still on the y-axis, so sure, no problem. As you can see, this one is really right and this one is not, so I'm not sure about the y position. So let's try to debug.log. Yeah, but I don't sure I will see anything, but let's try this. Let's try to debug this. Yeah, I've seen something like that. 1.5. Okay. So let's go back here. Oh, I forgot we've put our little material, so let's re-put something like that. Okay. So let's create a little sphere. We put this and it will have a size of 0, 1, 0, 1, 0, 1, and we've said that our size was basically this, so this is the main size, 1.8. So why do we can't have 1 minus this? Let's check. Of course I forgot to cast. Them are really strange the way it's behaved. Rotation, we take the identity. You know what? Might be the first rotation to the vector. So might be this one. Okay. So okay. This is basically what I had in mind at first. A little bit, but not too much, but so 0.8, okay. So identity, and then we simply change it a little bit. So we can simply try something like that, having some log going backward, a little bit backward. It gives some nice effect. And then we can add a little bit of rotation based on our min-max rotation. So let's try that. Let's see what's happened if we say that. So if I say a max rotation of 1, it would be really a mess. So it's okay. And if I say 25, we check. I'm not sure, but because the front is really too flat. I think this one is more interesting. Okay, with a little bit of course, a little bit of randomness. Okay, and we can change a little bit this also position just to be able to have some nice, to not have something really too how can I say that, to flatten the base. Oh, we need to reassign the mesh variable, it's missing. Okay. But it's I have some trouble to talk. It's more interesting now. Not perfect, but as I said already, I'm not searching something perfect, and I'm more about having something interesting and that might be pursued in a near future than something else. Oops, 2.5 might be too big. Okay, so we can now change a little bit our compute shader. Which is, yeah, it's here. So yeah, I said we can change it, and we can change different things. First of all, okay, first of all, we don't need let's keep that. This is the random per loop, the random per index. We don't need to change the position per index. We will not respawn it. Everything will be happen directly on the log, so it's not interesting. Then we don't need to the growth on the side, so I don't need to change this. So basically we will use the O scale. We will put this because we use the O scale. So we'll put this on the O scale if we need this. We don't need to redefine that. The position, of course, we need to redefine. The oppose, of course, it's the position, so not a problem. The east light time, why do we have this? Ah yeah, because we have the light following in the, okay, not a problem. The remap third time, the remap alpha, so let's keep this for a moment. Okay. So we could change directly in the compute shader the scale, in fact, if we want. For example, we could say something like so min scale random per loop. I don't need that, but I can say something like the size will be equal to the original scale multiplied by the normal position on the y-axis, which could be something like, as you know, float norm y, which is position dot y divided by 1.8, and use this like that, and now we'll have smaller feet, for example. Oh, you know, might be interesting. So I could use this by saying that min scale multiplied by this. No, min scale, in fact, min scale plus this multiply by this multiplied by norm y, which would give us something going from the minus value to the bigger value. So it's a big document, and we could create a norm y, a ping pong norm y, for example. So norm y could be something like so it will have a big belly, for example. So it could be 1 minus, because I want to go to 0, the absolute value of norm y multiplied by 2 minus 1 . Oh no, we have big hand, small head, small hand, so it's kind of interesting. Can also reduce a little bit the max 8, for example, and augment a little bit the min scale, sorry. And this could be really interesting, especially if we want to have some belly, for example. And we could take the 8, but I don't think it would be interesting. So yeah, the 8 is interesting, and we could say something like adding some curve, so in-out quad, for example, could be interesting on the norm y, just to add some curve directly inside our little guy. So if I say if I saturate this value, I can simply add a little bit of the head directly to this. Oh, identifier set. Oh, oui. And my French taking back. Okay. I'm thinking about having some big head and a big belly. So I would need a curve going from the base. So smaller. Actually, now my curve is like that. So let's not focus on the easing curve, but really just the linear curve. So going to the base, so it's smaller, bigger, smaller. So I could say something like that. Bigger, smaller, bigger. So for that, I would need to scale this a little bit. So if I multiply by 2 the value and taking only the fractional part of my computation, I would have something like smaller, bigger, smaller, bigger, smaller. And if I multiply by 1 by 5, I could have something like smaller, bigger, smaller, bigger. So if I say something like frac of this value multiplied by 1.5, this could give us what we want. Yeah, you know, big value on the head. So that was the idea. I freaking love to play with shader. So in out quad, let's check another easing cheat sheet. My accent is really not interesting. It's really not good. So yeah, right now I say in out quad, which is something like that. So it's not too element, too prominent. I could use a cubic, for example, or a quad, which would be small bigger. A circle would be, again, an elastic could be I think we have an elastic. Where is it? Yeah, I have it. Let's try this one. Might be really fun. I've created one. I would need to provide a second value, and 8 might be interesting. Okay. Not sure about the result, it might be really strange. Yeah. And you can see that some of the shape are changing their side. Why? Yeah, it changed its scale because some of the position on y-axis are moving because we are on the skin mesh. So you know these vertices, for example, if I say this movement, the y-axis changed. So I could take only the original position, but I will override it directly in this little transform, because I think in the shader we use it here, but do we need it somewhere? Original pose, yeah, because we normalize it when we try to ramp. Yeah, we ramp over this position directly, so we will need it. So yeah, I could put it in another matrix or etc. But so the in-out elastic is really not interesting. The cubic in fact might be something we could play with. So I will need to get rid of this elastic component. Kind of interesting, not perfect, but kind of interesting. We've used the quad previously, so the quad was interesting. The cubic is too much. The quad, let's check the quad. I think we will go back with the cubic, but easing, how do we say that one? It was a quintic and it was a quartic, so let's try the quart. What about the expo? We have a lot of them. We have also the quintic, so this is the quartz. The quintic is more prominent, so we can simply jump a little bit to the exponential directly. So I think it's expo. How do I said this? Oh no. And for this one I've said exp. Please forgive my naming convention. So we could little bit change some of this because we've used this. So now you see what I meant by something like smaller. I kind of like it. So let's check a little bit. Let's try to focus on a little bit of something. So we have the mean scale. In fact, we don't need this, so we could simply say something like that. Mean scale multiplied by this. Okay. And we need to change, of course, this by a float 3 if we want to keep the component norm y and norm y. Okay. So it's moving, and I don't want this to be, but the problem is the position. So maybe I want the opposition to don't move, which could be better. And now the mean scale will not be based on the position, but simply on the original position. Oh yeah, and now I see why I need the original position, because for the fur I need it for the velocity. So I think I will need to put the original position elsewhere. Let me see. Maybe I could put the vel. The vel is here and the opposite is here. So the opposite is the previous position. So I can use this here because I don't think I used the O scale elsewhere. Do we use it elsewhere? No. Do we use it elsewhere? No. Okay, so we have this, of course, OSC mat, but we use it for the vel only. So let's put the original, the previous position here. Okay, and now it would not be O scale. Okay, O scale is this, so O scale would not be our previous position. We don't use it here. I know it's not perfect as a naming convention, and I could basically take the oppose now, because the oppose will not be overwritten. And now we have our little guy here, and it's just like something, it's really interesting. I really like that. Okay, I like because it gives some cartoonist look, and now we can really focus on the fur. Okay. So let's add some fur if everything is okay for that. For the fur, we would need to activate every little bit here. Okay. I think a little bit about that. First of all, let's reactivate only the last one, the 1, 2, 3, 4, 5 last one, because at first I reactivate the first one, but the first one was too distributed, so it's really not interesting. Okay, sampler 2D half, I might have an error here because metallic. I need to sample this value, which is something like that. So let's say something like met would be equal to the metallic value of UV main text. Basically, we will take the UV main text. It seems to be simple plain color, so let's see if we can compile everything. Okay, so let's check. So we have our rug here, but of course it's fully imperfect. I know that. I would need to put some alpha into it. So let's take Photoshop. We need to take Photoshop to open our little log texture, add our fur distribution directly into the alpha, because I don't want to create a new sampler to the parameter, so it's easier to change everything on the shader side, so it would be easier. I need to log in my account. Okay. Let's see, activate this one. So I thought it was this one we've used, the fur 2. Then we can open in the model woodlog. in the albedo transparency, then I could simply let's duplicate the alpha. I think the alpha is this one, but I'm not sure. Yeah, this is the alpha. Okay, let's duplicate this, put in the log material. Ooh, it's really okay. I think it would be enough. Let's go this, deactivate this, take in this, and create a new alpha. Okay. Hey guys, we have an alpha. Okay, and this would be some PNG, so I will override. Oops, I need to deactivate this one. Okay, I would need to override the PNG element. Let's go back. No, I had some alpha. Why does my alpha doesn't applied? Does it come from the texture or does it come from another thing? So let's try to apply the fur, for example, when we were here. We had some fur which was here, and if I say OK, I have some fur. Basically it's come from my texture. It comes from the texture, right? We have this as the alpha, so I'm not sure about maybe I would need to create another texture and special fur texture, so yeah, I think so. I really don't like why I don't like that, don't know, but let's create another one. Okay, so this is not the main color, this is the vertex. Okay, so now back here, let's open a new sampler 2D vertex, and we will need to sample some of this. So fur lens, the fur multiplier, so we don't sample in texture here for that, but we sample in RGBR. It was this fur.a, which is now the main text, but the fur text. Let's try that. Oh. Okay, so let's again, I think I've made a mistake in the alpha, so okay, maybe the base texture hasn't as an alpha channel, so it might come from that. So now I have some kind of vertex. So does it work or not? Yeah, it's working. So now it's really working. So I was thinking about simply change the growth. In fact, I think it's really simple. I just need to sample the growth of the fur based on the noise, and the noise is here. So I could simply regenerate the fur length, and the fur.a would be also something else. So okay, let's take this. We need something like that. So do we have the UV? The UV are here, so let's recreate some UV. So this would be our base UV. Our base UV will be fixed. Okay, so we simply take the gravity text here, but changing by the vertex. Do we need something like a vec4 here? I think so here. So it would be a vec4. Let's go st here because I need that, and I don't need to change it over the time. So I just want to sample. So this is my UV. Then I have, of course, the position. This is here. So this is it's inside it here. Yeah, this is it. In the oppose, in the compute, we haven't put anything, but we have in our shader here, we have hypose, which is here. So can use hypose multiply by this. The time we have it. So this is our base UV. So now we can create something like that. And now we can smooth step, in fact a little bit like the time, but we can smooth step this by a noise value. So let's say noise length, okay, and this noise length is basically a value of so now we need a position, of course, because I will resample the noise. So I will need 3 value. The 3 value. Oh, the video has stopped on Instagram, so let me relaunch it. So I will stop the stream. We go back to the parameter. Go to the stream. So yeah. So let's add some uniform float. Noise fur based. Then noise fur sec and noise fur smooth. Oh. Did I write on cap or not? No, not cap. Okay. The three value, I will put them inside my shader based property. Yeah, so it would be header, noise per length. Okay, and let me put that here. Okay, apply. Okay, stop, start the stream. Let me check if the stream is ready. It is. Okay, we are. So this is basically something like that. So I need this string new value to be some data with a range from 0 to 1, which could be equal at first to 005 for this and 01 for this, and this would be noise based pose, for example, base pose. So this is the position of the noise, and we will go with the thickness, noise thick and noise smooth. Okay, so inside this I know add some length directly. And maybe I can simply put I can output this value in some data. For example, I have the ID, I have the data, I have oppose, so maybe I can say so something like float noise. It's noise. So noise length, something like that, because I will use it. So this would be O dot noise length. Okay, and this would be simply multiplied by this, and not the data.z, which data.z, remember, it was the it was our little time per instance. Okay, so something like that. Okay, and as I passed this, I think I will get rid of the light just for the moment. So the ramp is okay, it's based on the noise and the alpha, etc. So okay, but I will get rid of the light. And the fur would be multiplied by O by in dot noise length. So I hope this would be the solution, and I made something, an unexpected token somewhere. Yeah, forgot a parenthesis. Do we made another mistake? Yeah. And declare identifier norm time. Oh yeah, I haven't replaced this with our little value here. So remember, norm time is now this. Okay, light thick is now fur thick, and light smooth is not that part. Okay, so this might be good for this part. It seems to be compiling, so wait and see again. Do we have something or not? Let's check. Okay, look like interesting for me. We would need to change the value, of course, on our element here. So let's add some thickness of 0.5. So now we see we have some fur. Okay, so now that we have everything we want, let's keep the light for the moment. We will change it later. Let's reactivate all our fur here and wait until our shader properly compiled. Do we have some change here? Let's save it. Okay, and save and pray, my friend, for everything to be compiling quickly. Because if it's working, we might starting tweaking the last value before ending this tonight experiment. Do I have some air loss here? Oh my. Yeah, look into my air while it's compiling. But as you can see, a lot of the big hole here. Wait and see. Wait and see. Okay, let's check. Okay, so now we have our little fur man based, our fur man on our log. But if I reduce this, you can see now, haha, yes, we have some fur. So the noise might be a little bit too thick, of course. So if I want to go to 1, for example, and now something like that, and having some smoothness, for example, and I can simply change the alpha cut just to be sure to go on the base, because as you can see, we don't add the base at first for some of them, and we can simply reduce this to add some like that. Okay, so I think it's simply the noise which is too so this is the UV multiplier, so if I say something like that, it would be better. So if I want to get rid of some of the based elements, I can simply get rid of one of the iteration at first here, which start here, something like 0.25 for example, and this one, and 0.5. okay. Or not, 0.25 might be our first element, so maybe we can simply, so we still need to make some little tweaks because it's not really what I had in mind, but a little bit, and then we can change the color of the fur. Okay, so something that we can try is simply put the log on here and try to put our little shader directly on it. As you can see, it's okay. Well, as you can see, we have the shader is here, so let's change the gravity strength for the moment, so no gravity strength. Okay. 0.26. You can see I have some of this here. Okay. Yeah, I know. Okay. So now you can see my fur going directly on this little guy here, which is a little bit too much, I think. So I can taking something like that, and then I could change. So let's go to 0.5 and try to have some thickness of 1. Okay, and something that might be interesting is especially reducing a little bit the fur length. So I think I would need to change because we don't see the fur to this side, so might be we can change some of the fade thick. Yeah, this part might be better. add something different in here on the direction, the velocity, the fur length plus the fur multiplier. Maybe we can change a little bit that, because we are clearly knowing that we are starting at this position. So maybe we can say fur multiplier multiply by something like this, just to reduce a little bit the elements. Look like interesting now, because the fur are really directly on the elements. So let's try to play this. Yeah, this is really what I had in mind at first. It's really interesting, and if we try to go at scale 1, which is here, it's really interesting. So look like we have some fur directly into these elements. Or we could change a little bit the fur, of course, something like maybe more noisy, for example, if I can change it. Yeah, it's not taking anything on the sound. So let's open this and try on the assets texture fur, which is here, and I have this fur noise.tg. This is what I've used. Yeah, this was the fur noise.tga. So now I can reduce a little bit the length again. It's more spiky, so I'm not sure about this. I think I would prefer the little fur we had on the dog, which was this one. What's happened if I just put a little bit of, okay, let's duplicate it. I want to add a little bit of blur inside of it. Not what I had in mind. Yeah, so something like 0.5 for example. It would give us something more with more elements. So I would call this fur 3 and get rid of this. Does it work? I don't know, but we will check. Oops. Yes, it's in the fur. I was not sure about what I was putting inside. As you could see, I think it's more interesting, especially because I can put a little bit of more. Or can we put some strength into directly the curve here? So let's say something like 20. Yeah. And then reduce a little bit this. Okay. Let's try the thickness of our noise to 1, just to be sure to have everything. Okay. Nine. Okay. some of the fur seems to appear behind, above, sorry, the shape. So let's try to so if I reduce this, it would be simply the vertex position. Okay, so let's put something like that, so it would be inside the shape. I want to avoid the fact that some of the fur are going up. So let's change our color on the ramp 2D. Okay, so let's check if we have resolved our little problem of the fur going directly above the shape. I think so, but I want to be sure. Yeah, it's better. So let's reduce the time by the time of the animation, which is this, so we can change something like that. Oh, you can see some of them are still going above, and I really don't know why. Does it come from this? I think so. I think this is the problem. Okay. Okay, so I think we've made everything we wanted for this one. I will simply change a little bit of some of the colors, but we've made everything we wanted right now. So I hope you like this one. I kind of like this one. It's really interesting to have some color on this one. And I will simply say see you tomorrow for